All right, welcome to week 2, day 1, and we've been spending the last hour or so debugging people's Voroni assignments, and the bug in their code was caused by main.cc. When they were doing the hypot function, they were subtracting I, which is the row you're on, from the row of the city. The row of the city, however, was a unsigned integer. So if you got a negative result, whenever you subtract a signed and an unsigned integer, you get an unsigned integer as a result, which is one of those really bad design decisions made by somebody in the 1970s that has propagated to the modern day. So what happens if you take 5, you subtract 6 from it, and if either of those numbers is unsigned, then you, instead of getting -1, which you'd expect, you get max int. Okay? And so it was causing all of the cities to own their territories to the bottom right, but anything above them or to the left of them, which would have a negative distance, would overflow, and it would screw up all the Voroni calculations. And so the takeaway point here is that if you, whenever you're doing coding, always turn on all the warnings you can handle. Wall dash capital W turns on all warnings, and then I like to turn on extra warnings on top of that. And then that's actually not everything. There's actually dash W everything, but that's only in Clang, I believe. So let's run Clang, and it will Clang and make, and then it warns about all sorts of things. It's incompatible with C++ 98. We're not doing C++ 98, right? Everything's kind of garbage. I don't know. I'm not sure why. Implicit conversion changes signedness. Yeah. So there's a lot. You'll get lots and lots of warnings with everything on. Like probably too much. And that's a Clang thing anyway. So we'll just turn on wall and extra. And let's see here. Loop value variable type y, type const city creates a copy. Yeah, it does. It does at that. And so if you have an unsigned integer comparisoned with or subtracted with a signed integer, it'll usually throw a warning on it if you have all warnings turned on. Always pay attention to your warnings. Never, never, never let a warning just sit there. You want 0 errors and 0 warnings. Sure, your code will compile. Sure, your code will run. But as we saw, and we spent an hour debugging, even with undefined behavior sanitizer turned on, it doesn't catch the integer underflow as a result of that. So, because integer underflow is actually defined behavior when you have an unsigned integer, it's just not what it's not what you expected. Okay, so const city y in city list. So this is copying for every city in the city list. It's going to copy the city out. Since the city's fairly small, the performance hit on this is going to be minimal. But probably should be a reference. Like that. So if you do that, then instead of making a copy, it uses the actual city in the vector. And there will be a trivial and insignificant performance increase from that, but absolutely correct. Since it's const anyway, you might as well make it const reference. Turns off the warning. Now the thing caught a bug in, well, not a bug exactly, but a warning, threw a warning in my header file. And it's line 105, something like that. Yeah. And so I have a callback here. And so my callback had a parameter called row and column. And so what a callback is, it's a function that gets called by another function when something happens. And so I have the ability to handle mouse clicks inside of PuTTY. So if you click, it will send an event and a mouse click event. And if you have the callbacks, if you have the callback for a mouse handler turned on, every time you click, it passes it the row and the column that they clicked on. And by default, if you enable mouse events and you don't set a callback, then it calls this function here, and it prints to the screen, hey, it looks like you're trying to use a mouse, but you didn't set up a callback, so it's a little reminder to the users of my header file to enable a callback, and it's got some code and all that kind of stuff. Now, the compiler was rightly complaining that I declared these parameters and I don't use them. And so one solution to this is to actually just comment out the names of the parameters. Because a function is actually, most names are actually completely optional in C++. You only need a name if you're going to use it. And so you can actually create a function that takes int, and I can't get rid of the parameters because then it would have a different function signature than the callbacks. Every mouse callback has to be a void function that takes 2 ints. But this works because I'm not actually using, it's going to pass a row and a column to me, and I'm not doing anything with it. So this is fine. This will actually compile just fine. It looks a little weird though. Or I don't know if it looks weird. I could just type int comma int, but leaving row and column in here is useful for people who are reading my source code who want to make their own callback. And so there's a more modern way of doing this. I believe modern C++ has added these things called attributes. And so attributes are a really nice feature. You can do things like, say, no discard, like that. No. Like that. And no discard means the return value of a function can't be discarded without a warning. So like if you have a function, it doesn't make sense on a void function. Is that what it's, yeah. Let's say I make a function called int absolute value, takes an int, return if x is less than 0, return -1 times x, otherwise return x. Right, so I just made a little simple absolute value function here. And so if somebody calls absolute value, like let's say they say int y is equal to absolute value of -5 or whatever, this would be just fine, right? And it wouldn't warn on it. Assume this is in main. However, if they did this, if they just called absolute value of -5, because some people might assume that absolute value is called by reference, right? You pass in a variable to it, and it absolute values that variable. And so this could very well be done by somebody who doesn't know if absolute value is called by reference or called by value. If it's called by value, you pass the value in, you get a value out. If it's called by reference, you pass the value in and it changes it, right? So somebody might try to do that. And this is perfectly valid C++. You do not have to catch the return value of the function. So they've added an attribute called no discard, which if you do this, it'll throw a warning. It'll be like, yo, absolute value is completely pointless unless you do something with the return value. And you can even pass in a parameter here. Ada, somebody's calling me. Ada, it's Grandma. Here, go take the call. You should.
Dad, it's
I'm lecturing here. Talk to Grandma.
Dad, it's supposed to be.
Talk to Grandma. Okay. Okay. So if they call the function in main like this, then it will print a warning saying, "Hey, absolute value returns the absolute value. You should catch it." So you guys understand? So this is all like modern C++ stuff, and it's there used to be like compiler-specific attributes you could turn on to do that, but like if you switch compilers, they wouldn't work anymore. So, there is one called. Let's see what kind of attributes we got here now. C++, we got no return, which indicates a function doesn't return. Like if it's exiting a function, that would be a no return function. Like if it's exiting the program, it's calling exit. Because sometimes the compiler's like, you know, like if you, it sometimes doesn't know what to make of your code if a function doesn't actually return anything because it's a function, right? Deprecated, if you put that tag onto one of your functions, you can be like, hey, this is an old function. Java's had this since forever. So if you use a function that's been deprecated, then you can be like, hey, we're not using hash table anymore. We're using hash table 2 now. You should probably switch. It's just better. But we can't get rid of the old thing because it'll break everyone's code. So what the developers can do is they can put a message in there for people using their code and be like, hey, by the way, there's this better alternative now. Fall through is used with switch statements. So if you have a switch statement, you have different cases. Normally you put a break in between each one, so it breaks out of the switch. Sometimes, though, you want it to fall through to the next case. There's different optimizations you can do with that. And so you put the fall through tag on there so that the compiler doesn't warn you about it, because normally compilers are like, you goofed. You didn't have a break statement. So whenever function's not being used, yeah. And so notice card, we just talked about, if it throws a warning if they're not catching the return value on it. Maybe unused is the one we're about to use here. Likely and unlikely is used for optimizations. And so if you've got like an if statement and one branch is very, very likely to take place, the other one's not, you can tag it with that attribute to tell the compiler what it should optimize for, what you, the programmer, expect is going to happen more often. And that can actually make a pretty big difference on performance if the optimizer doesn't guess correctly. Yeah, don't need to worry about the other ones. Okay, so maybe unused. There we go. So you just toss that in front of a parameter, and then if this works correctly, it should just hush up about the. Okay. Yep, no warning. Okay. So by putting that attribute in there, then it suppresses the compiler warning on it. And it normally, like, maybe I wouldn't worry about it too much, because unused parameters are like low tier, like, warnings. The signed unsigned comparison, sometimes it doesn't matter. Like if you're going for anti equals I is less than vector.size, that it's not going to cause a problem because your integer is never going to be negative, and it's never going to be bigger than 2 billion, probably. So it's fairly harmless. However, some of those signed-unsigned comparison things, like we saw, they can cause hours and hours of debugging because it was creating a very silent integer under flow. It was wrapping up to maxint, and then the distance calculations were getting screwed up. And the only sign of it was that the numbers were not, like the colors were not coloring properly. Unused parameters, low tier. Like, it's not going to cause a bug. At worst, it just means like you're in development or something, and like, you're passing in 3 parameters and you're kind of developing it and you haven't gotten to the third one yet. And it'll keep throwing a warning like, hey, by the way, you should probably do something with that third parameter or get rid of it. In the case of my header file here, though, it's a case where like I literally can't use it because it's a callback. The callback has to have these 2 parameters for it to match the function signature for the mouse handler. And so literally I can't use these parameters. So either I could just comment out the names, which is fine, or I can just tell the compiler, yeah, I'm not using these things. I know I'm not using it, but they need to be there. And that's probably the preferable way of doing it. Like, yeah, I understand they're there. I'm literally not using them, but they have to be there. So that's why that attribute exists. It just suppresses a warning. And when you Can
I have one at your yield?
Yeah, go for it. And it's really important for a header file that you're sharing with the world, because if I share this header file with the world and it's used by all of 3 people or something like that, or my students on the server, then every time they compile with warnings turned on, my header file is giving them warnings, and that's super annoying. And so it's really important to be proper when you're doing header files and sharing them with other people, because all of your warnings become their warnings, and they get annoyed at you for it. Okay, ceasing. All right, so I think that's good for today. Tomorrow I'm going to be in Big Bear. I guess we'll just talk about relaxations tomorrow then, and convex holes tomorrow. I think this was a good lecture, a good learning experience for you guys today. C++. Can you go over the last part of the code? Sure. Yeah, no problem, Biddinghoven. And make sure that it's all working and stuff like that. I'll grade it tomorrow. I think there's an easier way to do it. Okay. Become Zekian, cd Voroni. So yours is a size _ t still. Okay. Pot. Yeah, you're probably going to have the same problem here with Zekian. So one thing you could do is you could actually just cast this to an int, and this is another way that you can do it. You might want to do that. The big city calc. All right, so randomize cities. There you go. Yeah. So your code has the same problem with Zekian. See how they're not centered? All of your things are in the top left corner. It's because of the same thing. It's the integer underflow problem. Signed integer underflow, which is not undefined behavior. Again, unsigned integers, when they overflow and they underflow, it's defined behavior. It's signed integers, it's undefined behavior, which is why the ubsan undefined behavior sanitizer wasn't erroring on it. It's actually not undefined behavior. But yeah, you need to fix that code as well, to fix the underflow problem. The big city calculation, sure. Let's go into read-only mode and go to the bottom here. Place back. Max element. Oh yeah, you're using STL. That's good. You're doing 3 loops to compute the big city. Yeah, what I did was as I add tiles to a city, then I increment their size, and then max element, compute, begin, compute, and what are you doing here? Yeah, this is, no, you don't need to do any of this. You don't need to do any of this. All you need to do is say, for every city in the city list, find the one with the biggest size. That's it. So, yeah, all of this computation here is pretty much meaningless. You only need really to do one that's like that. You probably do it using the STL, using the, yeah. Let's see if we can. Here, Bazookian, quit out of your file. Let's see if we can quit out. Sorry. Quit out of your file. Quit out of your program. You got it open right now. You're not open? All right, cool. All right, so I don't think. Let's see if we can do this in modern C++. Okay. So let's do a city. Let's see, auto iterator equals max element of the city list. City list dot begin. City list dot end. If we're using the ranges library, we actually could just pass it city list. And we're going to pass in a comparator using a lambda. Let's see. How do I want to do this? Let's see. City by reference A, city by reference B, and we will return if A dot size is bigger than B dot size, and I might have that backwards. What's it called? Name? Is that the name of the city? Name? Let's see if that works. Okay, it's backwards then. Okay. Okay. So, what did I do here? Yeah, usually when sort, because it's max element, right? Okay. Yeah. Okay. So let's explain what we're doing here. So max element is an STL function that finds the biggest thing in a vector or whatever. And so I'm passing in the vector of cities, citylist.begin, citylist.end. So that's the whole vector. It's a range from the beginning to the end. It's going to go through every city, and it's going to compare them using this function that I made right here. So this function is a weird looking thing, right? It's something called a lambda. A lambda is a anonymous function. So it's got no name. It's only used in the context of this one function call here. So we're actually passing it a function as the third parameter, and the lambda is being used to compare two cities to see which one's bigger. Another way we could have done this is up here in the city class. We could have made an operator less than, and the operator less than could compare based on size to see which city is bigger. Yeah, we could probably do that way as well. A lot of times, though, it doesn't make sense for you to use one specific attribute to always sort by. But for a city, I think size is the only thing you would really ever compare a city on. So I guess it makes sense in that context. But okay, so lambda is an anonymous function. The syntax is open close square bracket, open close parentheses, open close curly boys. And so this is actually a valid anonymous function. It's a function that returns nothing, takes no parameters, does nothing. But you could pass it as a, it's a function. This is actually a legitimate function in C++. So the square brackets are used for what are called lambda capture. It can capture variables from the enclosing scope. Not doing that here. The parentheses are the parameters being passed to the function. In this case, it takes two cities. Anytime you're doing anything like sorting or max element or min element and that kind of stuff, it's expecting there to be either a less than operator or a function that takes two, probably make these consts actually. Make it a little more proper. I think that should work. A little more proper that way. So we're passing it's expecting there to be a comparator that takes two cities, and it passes the two cities. So it's going to go one at a time down the vector, always recording who the biggest person is, and it uses this function to compare them. And so in this case, it's comparing the two cities based on their size. And so whichever one is bigger is retained, and then it's going to compare the next city against that one, and whoever wins is the new champion, and it just goes all the way down all the cities until it finds the absolute maximum. And then it returns an iterator pointing at it. And an iterator is like a pointer, but kind of a class version of a pointer. And so it's a pointer. It basically works like a pointer. And so you have a pointer pointing at the element in the city array that's the biggest. And then we just output its name by using the arrow operator. We're saying output its name, output its size, and there you go. So max element is an SQL function that does, I don't know, whatever it is you're doing here. And similar to like the Voroni calculation here. This kind of stuff where you're like always finding the greatest this is the minimum, right? Trying to find the minimum distance. Same idea, but it's one line of code. So, isn't max element need a pointer? Max element returns something that looks like a pointer. It's actually an iterator. An iterator is actually a class, but it has an overload for the arrow operator on it that makes it behave like a pointer. And so it's a pointer is actually a primitive type. It's an integer, really. If you actually look under the hood, what is a pointer? It's just an integer. It's just a memory address of where the thing is. And so if this was returning a pointer, it would just literally be the memory address of the biggest element in the city list. It's not actually. It's actually returning a class. And so iterators have a lot of overloaded things on them, like the plus operator is overloaded, so it points to the next element in the list. And they have a distance operation on them where you can see how far apart two iterators are. Things like that. None of it really matters because we're just treating it like a pointer. And since it has an overloaded arrow operator on it, you don't have to know that it's not a pointer. We typically use auto with iterators because iterator class names are actually really obnoxious, pretty long. So that's why the auto keyword exists, is to hide the stupid long type name of iterators. Yeah, what would it be? The actual type name of it would be vector of city : iterator, something like that. Yeah. And they can get much longer than that. Like you can have a reverse underscore iterator and the type names and things, like the things can get obnoxiously long. And so the auto keyword really exists to just compress down the length of the type names for iterators. And also so you don't have to remember that bit of trivia. Okay, so, and then, it's not actually a pointer. It's not a city pointer. It looks like one, but it's not. And so, but you can use it like one. So we're just pointing to the name, pointing to the size, and there you go. And so this little bit of magic here allows you to compare two cities any way you want. In this case, it is comparing them based on size, but I could change it to compare them based on the name or their color values or whatever. And so lambdas are just really nice for like one-off functions that you're not going to use a bunch of times. If you're going to use a function over and over again, you should actually make it into a function. If your class always sorts based on size, make a less than operator for it in the class. But for things like this, where you just like one-off, I need to find the biggest, thing based on size in this vector. There you go. Spit it out like that, and you don't have to add things to your class, to support. It's a little weird, right? To have to add things to your class or add global functions next to your class to support your code using the class. You know what I mean? Like the people using your class can kind of do their own thing this way. Okay. So, yeah. Okay. So more C++ trivia today. Talked about attributes, talked about lambdas, signed unsigned comparison, why you should always turn all of the warnings on and resolve all of the warnings, because both of you guys ran into hours and hours of bugs that were hidden by the underflow. Okay. So, yeah, good learning day. So I'll pick it up again tomorrow, and we'll continue our discussion of computational geometry then, and you'll get your next programming assignment tomorrow. Okay, so I'll grade them all then. Peace out. Do the warnings involve much more serious errors later on? I don't know. Uninitialized, there's a lot of warnings, right? Like, some of them are more severe than others, right? Using an undefined variable is like a pretty bad thing. It's valid C++, right? Like if I were to come up here and be like, int, whatever, cout, whatever. If I'm using an undefined variable like that, then why is this taking so long to compile? You're getting a warning. It's on an error. It's on an error. In Java, that would be an error. It's just a warning. You really don't want that in your code. Like if you're, for this, it doesn't have any side effects. It doesn't matter. But like, if you were actually using this variable, for determining if your defibrillator should activate and shock somebody's heart, that's really bad. It's just a warning. It's not an error. It compiles. It runs fine. Most of the time, it's even 0. And in fact, with the optimizer on, let's run it. 32591. Let's compile it again with the optimizer on. -03. Yes, bro. What's up?
What time do you get out of class?
We're basically done now. Why is it taking so long to compile? It's a really long compilation step for not a big program either. It's kind of weird. Like this is obnoxiously long to compile it. With the optimizer on, you get 0, and that's actually really deadly, Aaron. It's really deadly because you might run your code and you just assume that it's going to be 0, and every time you have the optimizer on, it's 0. Then one day you're like, I'm going to turn on debug mode, and then when you turn on debug mode, you disable the optimizer, and then your code explodes because you're assuming that the variable would be initialized to 0, and it's not 0 anymore. Or sometimes it's 0, sometimes it's not. And then you'll see all these people going on to like Microsoft's forums being like, yo, debug mode doesn't work. It works fine in release mode, but when I put on debug mode, it explodes and the code crashes and seg faults and stuff like that. Fix your compiler. And the question is like, all right, how many warnings do you have? If your code is exploding in debug mode, it could be due to a race condition. Like if you have multi-threading, that's a possibility. Most of the time, though, it's because optimizers will actually hide bad practices a lot of the times. Like if they see that your code isn't being used, it'll delete it. If you've got a variable like this that isn't being used anywhere, it just makes it 0. And so it can actually hide bad practices. And so that's one of the reasons why you just need to get into that habit of like always clearing your warnings. Never let them lie. The only warning that I'll ignore is an unused parameter. Like, especially if I'm doing development. Like I'm writing a function and I've got, one of the parameters used and the other 2 aren't used yet. Unused parameter. Okay, fine. I'm still working on it. Okay, 2 of them are done. Unused parameter. Fine. Get all 3 done. Okay, I'm good. But I leave it in there because it's a reminder to me that I'm not done with the function yet. Like I'm still working on it. And to not like forget, like if I get most of the way through it and I forget to finish it, the warning will be like, hey, you have an unused parameter. Oh, yeah. I was supposed to include compound interest too. That's right. Okay. So, yeah. So things like unused parameters and unused function calls and things like that. Yeah. They're not going to kill you, but I always leave all the warnings on. Oh, like wall gang forever, Always turn on all your warnings and clear your warnings. It's just good practice. So otherwise, C++ is a very dangerous language. Otherwise, you know what I mean? Like, in Java, it just won't compile. If you do this, if you try outputting an uninitialized variable in Java, it will not compile. the compiler will literally throw a warning at you, or not a warning, an error. It'll throw an error at you. In C++, like, all right, if you want to, you know, if you try compiling it with, you know, warnings turned off, if you try compiling with warnings turned off, you get nothing. You see that? We're outputting an uninitialized variable. And there's no warning by default. So, yeah. So that's just good practice in my opinion. C++ is a perfectly reasonable language to develop in. It's developed a reputation as being hard and difficult for beginners and things like that. But really, if you just have the right compiler flags turned on, all warnings, address sanitizer turned on, ubisan turned on, if you've got your development environment set up right, like, it's no easier or harder than any other language, honestly. Let me get rid of that for you. For Voroni, the coloring square issue we're having, where should I look for the solution? It's the signed integer overflow. Remember that, Guzikian? We talked about that earlier. When you subtract the row, which is an int, from the row of the city, which is an unsigned integer, if you get a negative value, then you get unsigned integer underflow. It wraps around to max int, and the distance is reported as being 2 times 10 to the 19th power. That's why all the numbers to the left and above you are not coloring properly, because you're doing a signed to unsigned subtraction. You need to make sure they're both signed, so you can cast. You can either change the type of the city's row and column to be int, which works fine, or in the hypot code, you can cast the city's row and the city's column to be int around that. That'll work fine too. So what would the likeliness if you have an unresolved error in the main? Explain? I don't know what that means. I didn't fix it in yours. I fixed it in Binninghoven's. So you need to fix it yourself. So what would the likeness if you have an unresolved error in the main? If you have no errors displayed in the code, that you have an unresolved error. Well, there's no, like, if you're compiling and there's no errors, there's no errors. Like, do you mean like a logic bug or something like that? Yeah, happens all the time. But logic errors you can get just as easily in Python, Java, C++. You know, it's, the only bugs that maybe you can get in C++, not in Java, is like, in C++ you have to choose whether you call by value or call by reference. Like, do I clone the thing that I'm passing to it, or do I pass the original thing to it? And every time you have a function, you have to choose whether you want a duplicate of the original value or if you want the original value passed in. In Java, for primitives, ints, floats, doubles, it's always a duplicate, it's called by value. For everything else, it's called by reference. Everything's called by reference. And I think it's the same way in Python too, right? I think. And so in C++, you have to manually choose which one of those you want. And that can sometimes get you into trouble. Like, you pass in a copy when you think you're passing the original, you change it, and then nothing happens back in main. You're like, you know, that's about it. Other than that, the same logic bugs you get in Java and Python you'll get in C++. Not a big deal. Okay. That's it, guys. I am off to hit the highway. I'm going to go up to the mountains tonight, and I'm actually going to take my second monitor here, my webcam, so I'll have a dual monitor set up for tomorrow, so hopefully everything should be fine. See you tomorrow.